The term periodicity refers to the fact that there are trends in the properties of elements as we move left and right or up and down on the periodic table. Let's define a period as a horizontal row in the periodic table. There are 7 periods. They are numbered down the left side, as I've shown here at the bottom of the screen. Now you might wonder what these 2 rows are doing down here below the main body of the periodic table. Well, if we were to put those into the main body of the periodic table, the table would instead look like this. And it wouldn't fit very well on an 8.5 by 11 piece of paper. Furthermore, we don't often talk about those elements, and so by convention, periodic tables are put together with those elements at the bottom. A group, or a family, is a vertical column in the periodic table. There are 18 groups numbered, as you can see here, across the top. Again, if the elements at the bottom, which we sometimes call the F block, if they had been put in the main body of the periodic table, we would have 32 groups instead of 18, and so for convenience we put those elements at the bottom. Let's review, why is a group also called a family? So let's write some shorthand electron configurations for these elements. So it would be helpful if you had a periodic table to refer to. I'm going to assume that you understand electron configurations and have gone through that before, so I won't review that here. For lithium, the shorthand electron configuration is going to be helium 2s1. For sodium, it's going to be Ne3s1. For potassium, argon 4s1. And for rubidium, for example, it'll be krypton 5s1. Recall, to write shorthand electron configurations, you write the symbol of the noble gas that precedes the element in square brackets, and then you pick up from the next period in the table until you have finished your electron configuration. We can see that each of these elements, which are in the same group, they're in group number 1, they all have 1 valence electron. How about this next set of elements? The noble gas that precedes oxygen is helium. Then we continue from the left side of the table, 2s2, 2p4. Sulfur, which is right below oxygen, would have Ne, 3s2, 3p4. Selenium is below sulfur in the periodic table. Its shorthand electron configuration would be argon 4s2, 3d10, 4p4. Recall that whenever we go into the D block, we go down 1 number from what we started, and then when we come out of the D block, we go back up 1 number, which is why we write here 4s2, then 3d10, then 4p4. Similarly, for tellurium, which is right below selenium, we write krypton 5s2, 4d10, 5p4. So, all of these elements on the left are in the same family, and all of these elements here in the middle of the screen are also in the same family. Now recall that we count valence electrons as the s and p electrons in the outer shell. Therefore, in selenium, these 10 3d electrons are not considered to be valence electrons. Similarly, for tellurium, these 10 4d electrons are not considered to be valence electrons, which means that all of these elements, which are again in the same family, have 6 valence electrons. This brings us to periodicity trend number 1. Elements in a family have the same number of valence electrons, and therefore they have similar properties.